Welcome once again to this channel. We are going to look at how the vector error correction model is estimated in EViews. Okay, so without wasting much time, let's get right to it. So the first thing we need to do is to import our data set here. Okay, so you go to File, then Import. Go to Import, then you select where your data set is, then click Open. Okay, so we have our data set here. Click on Finish to import your data set, then yes. So we have our data set here. We have our variables GDP and then oil. Okay, so since we are estimating the VECM model, we don't need to check for stationarity in our data set. Okay, so we go on by estimating the VR model so that we can select our optimal lag for the VR model. Okay, so just click on GDP here, hold the control button and then click on oil. Then you open it as var by right clicking here and then going to VR as var. Okay, so we click on it. You can maintain this one and then click on OK. So this is not what we are interested in. We are interested in the optimal lag. Okay, so you go on by clicking view here, then you go to lag structure. Okay, so under the lag structure you select the lag length criteria. Okay, so when you click on it, see for the VECM model, um, when the lag is less than 1 or less than 2, it will bring autocorrelation problems. Okay, so let's maintain the 8 here, or you can choose 5 or 6. So let's maintain this 8, and then this is what we have. So these are different information criterions here, and then you can see that the AIC has the least information criterion here, and then it is selecting optimal lag to be 3. Okay, so here we say that the optimal lag for the VR is 3. Okay, so after selecting optimal lag for the VAR here, then you go on by checking for cointegration. Okay, that is to check for long run relationship between GDP and oil here. Okay, so you go to quick here and then select group statistics here, and then you perform the Johansen cointegration test. So this is the Johansen cointegration test. You click on it and then you see your variables are listed here. So here we are selecting GDP as our dependent variable and oil as our independent variable. You can change these ones. Okay, so you click on OK, and then this is asking you what is the lag interval. The lag interval for the VR model, it is 3, right? So you select the 3 here, and with these ones, based on your data set, you can plot your data set to identify any trend or some variations in your data set, and you can select this one. But for this particular research, you select the intercept with no trend in the VR. Okay, and select click OK. So this is the results for the co-integration test. Okay, so to check for the co-integration test, it's the result is based on two things. Okay, that's the trace statistics and then the maximum eigenvalue statistics. Okay, now if the trace statistics is greater than the critical value at 5% level, we say that the variable, there is a co-integration in our variables. Okay, the none here means that there is no co-integration equation in our variables. Okay, and we can see that the trace statistics is greater than the critical value at 5% level, and then here we say that there is at most one co-integrating equation in our variable, and we can see that the the trace statistics is greater than the critical value at 5% level, and we can see that the p-values for all of them are significant. Okay, they are less than 0.05, which means that we have to reject the null hypothesis and say that there is co-integration in our variable. And you can see here that it says that the trace test indicates two co-integrating equations at 5% level. Okay, now let's look at the maximum arguing statistics. So with the maximum arguing statistics too, we can see that they are all greater than the critical value as 5% level, and the p-value too also supports it. So when you see the star here, it means that there's co-integration in your variable. Okay, so which means there is a long run relationship between your variables. So you go ahead by estimating your VCM model. Okay, so remember that I said for the VCM model, the optimal lag for the VCM model is the VR optimal lag minus 1. Okay, so if the optimal lag for the VR model is 5, then the VCM model, the optimal lag for the VCM model is going to be 4. Do you get it? So in our case, the optimal lag for the VR model was 3, so the optimal lag for the VCM model is going to be 2. Do you get it? Alright, so we go on by estimating our VCM model. So to estimate our VCM model, let's just delete this here and then delete this one too here. So to estimate the VCM model, you just open the variables as var again, and then we select the vector error correction. Okay, with the vector error correction model, there is no constant here. Okay, so what was the optimal lag for the VCM model? Is 2, right? Because the optimal lag for the VR model was 3, so the optimal lag for the VCM model is going to be 2 here. After that, then you base on your model. If you have any restrictions in your VCM model, you select it here, and this one too, based on your research, you can select any of them here. So when you are done, you just click OK. So this is the vector error correction estimate. Okay, so you can see the long-term relationship between the variables here, and here you can see that oil has a negative relationship with GDP in the long run. Okay, that is, an increasing price of oil will decrease GDP, and then a decreasing price of oil will increase GDP. Okay, so this one is the adjustment coefficients here. Okay, so the signs in front of the numbers is what is important here. Okay, if there's a negative sign in front of the coefficients here and it is significant, it means that there's a long run relationship. So here we can see that GDP has a long run relationship with itself and um, oil. Okay, and oil too has a long run relationship with itself and GDP. So with these ones are the adjustment speeds. Okay, so with this one we can see that on average, all other things being equal, um, the current period adjustment speed corrects prior years deviation from long run equilibrium at, let's say, 31.07% for GDP. Okay, and we can do same for oil. So the rest here are the short run coefficients. Okay, all right, so you can do further analysis of the vector error correction estimates by doing the Granger causality test, the impulse response, or the variance decomposition, which will be looked at in other video. Okay, right, thank you.